Balancing chemical equations. Why do chemical equations need to be balanced? The law of conservation of mass states that mass can neither be created nor destroyed. What that means when we write a chemical equation is that what we start with in the reactant has to be the same as what we end with in the product. When we do things like stoichiometry, we have to have a balanced chemical equation. Some other practical uses for a balanced chemical equation would be limiting reactant problems and percent yield problems. Obviously, there's many other chemistry problems that require a balanced chemical equation, but these are a few things that we're going to go over. The whole point of a balanced chemical equation is to get the same number of atoms on both sides. We may be tempted to simply put an additional subscript on the oxygen right here, so we would have two oxygens on the product and then two oxygens in the reactant, but we can't do that. If you've looked at some of the previous videos, we know that this abbreviation for water literally means that we have a molecule that looks like this. And if we would add an oxygen right here, then that would literally change the molecule that we're representing. So we can't do that. So the only other way to balance the equation is with coefficients. If we put a coefficient in front of water H2O right here, let's take a look at what we're doing here. What that means is we have a molecule with two hydrogens indicated by the subscript of 2 and an oxygen. When there's no subscript on the oxygen, that's just assumed to be 1. So what we're doing is taking the coefficient and multiplying the hydrogen, and we have 2 of them, so we would then have 4. And then we're distributing the 2 to the oxygen, and we would have 1, so that would be 2. Let's look at another example of carbon dioxide, CO2. What we are looking at is a molecule that has a carbon and an oxygen in it. There's 1 carbon and there's 2 oxygens to start out with. If we put a coefficient of 2, the coefficient is distributed throughout the molecule. So we had 1 carbon times 2 would give us 2 carbons, and 2 oxygens times 2 would give us 4 oxygens. Alright, so far we know that in order to balance a chemical equation, there has to be the same amount of atoms on both sides of the equation. And we know that we balance the chemical equation through coefficients, not through adding subscripts. So let's just divide this in half, where we can have the reactants on this side, and products on this side. So we have hydrogen and oxygen in the reactants, and we have hydrogen, oxygen, in the products. With the products, we have 2 hydrogens and 1 oxygen. The reactants, we have 2 hydrogens and 2 oxygens. The first thing that we notice is the products do not have enough oxygens. Now we have to put a coefficient of 2 in front of the water molecule. This would then change the number of atoms, where we have 2 oxygens and 4 hydrogens. Now it's obvious that the products have twice as many hydrogens as the reactants. So we come over here to the reactant side of the equation, and in order to get 4 hydrogens, we put a coefficient of 2 in front of the hydrogen, which would give us 4 hydrogens. And now we can see that we have a balanced chemical equation. The hydrogens both have 4 right here, and the oxygens both have 2 right here. Alright, let's say that we want to mix nitrogen monoxide with oxygen to synthesize nitrogen dioxide. We can write this in a chemical equation as NO plus diatomic oxygen, the product of nitrogen dioxide. Alright, so now we want to balance both sides. We have nitrogen and oxygen, both sides. On the product side, we have 1 nitrogen and 2 oxygens. And on the reactant side, we have 1 nitrogen and 3 oxygens. If we put a coefficient of 2 on nitrogen dioxide, we can distribute that out, and we would arrive at 2 nitrogens and 4 oxygens. Going back to the reactant, we can balance this by putting a coefficient of 2 in front of nitrogen monoxide. We can distribute that out, and that would give us 2 nitrogens and 2 oxygens plus the diatomic oxygen right here, and that would give us 4 oxygens. So on the reactant side we have 2 nitrogens and we have 4 oxygens. On the product side we have 2 nitrogens and 4 oxygens. So the equation's balanced.